Die Sprachübertragung beginnt jetzt. Alle Teilnehmer befinden sich im Zuhörermodus.
Hello and welcome to our today's webinar. Our today's topic will be the NIRS UMB, our contact-free measurement on the road. This is a part of the Luft traffic segment, and I will inform you today about the installation, about the measurement principle of the NIRS, about the maintenance of the NIRS31. First of all, I will show you some general things here. For example, my person. So I'm Manuel Kreissig and I'm working here at Luft for 14 years now in the service and support department. You will see also my email, so if you have any other questions after the webinar, you can of course send me an email to this email address if you want. Also, you will be able to use this webinar interactive. That means you can also ask questions if you want. There is a question box on the right side of the software, of the webinar software, which is called questions, and you can enter questions there. And we will do some breaks during this webinar where you can, of course, ask this question, and we will also answer the questions, okay? So please use this question box. Okay, let's start. How to measure with the NIRS UMB. The NIRS UMB, the measurement principle, is a non-invasive optical spectroscopic principle. That means, you can read that, light generated by a light source in the NIRS will be guided to the road. Depending on the road condition, that means if there is water, snow or ice on the road, specific bands of the light will be absorbed. And that's the key word here, absorption. And with this absorption, we will change the light. And that means the reflected and changed light can be analyzed by the receiver using 4 filter plates. You will see here a picture of the NIRS, and you will see that this big hole is the light source. Behind the big hole there is the light source, and the small hole at the top there is the receiver with the 4 filters. I will show this live here now. So you will see here now the NIRS, and again this here is our light source, and you will see there is a plate here. That's an infrared filter plate. That means, of course, you will not see the light as a driver or as a person standing in front of the NIRS. You will not see the light because there is this infrared filter plate here. And here at the top, this is the receiver. And in front of the receiver, you will have 4 filter plates. They are moving. There is also a plate with the filters installed, and this is a moving plate. And so we will analyze 4 different bands with these filters to get the measurement values. Right. So here we see all the different measurements which are possible. Of course, the first thing is the layer thickness. I told you this is this change of light which is used here, this optical measurement principle. That means we can analyze if there is water, snow or ice, and also the thickness of this different parts on the road. That means up to 2 millimeters we can examine water, snow or ice, snow also up to 10 millimeters. So that's the first analysis here. That means we can check the layer and the thickness of this layer. The second thing is that we also use a pyrometer. The pyrometer, I will show you that, is installed here. This is the pyrometer here, which is used to measure the temperature. And the pyrometer is a type of thermometer, and it's a non-contacting device which can measure the thermal radiation on the surface. The thermal radiation can be used to determine the temperature of an object surface. Okay, so also this is a non-invasive method to measure the temperature on the road. So with these 2 values, that means with the input of the layer and the thickness and the temperature, the surface temperature, we can calculate the road condition. So these two parameters are used to calculate the road condition. And the road condition is a calculated value, and you will get values like dry, damp, wet, ice, snow, and critical wetness, for example, which are based on the layer thickness measurement and the surface temperature measurement. The next point you will see is the freezing point. This is a unique thing of the NIRS. We are able to give you the information about the freezing point temperature and the salt concentration, which is not measured. It's a calculated value based on the ice percentage measurement. The sensor will be able to measure the ice percentage on the road. That means depending on the ice percentage, we can calculate the freezing point temperature and the salt concentration. Now, the people of course ask me often, what will happen if there is no ice percentage measured? So that means ice percentage measurement is 0. In this case, you have two options. The first option is that the sensor will give you the information 0. So that means freezing point temperature 0. For example, if you have a surface temperature of -4 degrees and the ice percentage measurement is 0, then you can choose the first option, which is 0, so that you will get the information freezing point temperature is 0. And the second option, which you can choose, you can configure that with the UMB config tool on the NIRS, is that you will get the surface temperature, the actual. That means -4 degrees, for example. Also as a freezing temperature, because this is the minimum freezing temperature, because the ice percentage measurement is 0. I hope that's clear. So these are the two options which you can choose using the UMB config tool. Of course, in addition, we have the snow height measurement. I told you that, up to 10 millimeters here. And we have another measurement called friction. The description of friction is, friction describes the grip of tires on the road surface. This can be reduced as a result of environmental influences such as rain or snow. The value of the friction is scaled between 0.1 and 1.0. High values indicate a good grip and low values indicate a bad grip. The highest value is reached in dry road conditions, of course. If there is water on ice, or ice, the lowest value is the result. You see that. Measurement range between 0 and 1. Critical is 0 and dry is 1 in this case. So that's the friction output of the NIRS31 here. So these are all the different measurements which you will get if you use the NIRS31. In addition, we have of course the possibility to transfer the data. We have different protocols which can be used to transfer the data here. We have of course our Luft binary protocol, our standard Luft UMB protocol here. We have ASCII as a possibility, and we have SDI12 also. So also the sensor can be used in SDI12 mode. We have a maintenance-friendly version of the NIRS. I will show you that anyway later when we will talk about the maintenance. Also the on-site calibration, I will give you the information how to do this calibration, which is called adaptation normally, with the NIRS31 here. But first we will now talk about installation. So these are the technical specification. Now we go to the installation here. The NIRS31 can be installed, for example, using a mast. And you will see, if you use a mast, we will have something like a right triangle, like a right angled triangle, it's called in English, I think. That means the important distance here is the C distance, which is, if you explain that in a mathematic way, it's the hypotenuse, right? Remember the school days here, the Pythagoras. So the important thing is that the measurement distance C is limited. That means you have to use a distance C between 6 meters and 50 meters. And that's a must. In this case, if you want to be inside a specification, of course, the mast length, the height of the mast is also limited. That means you can start with a mast minimum 4.5 meters, and I think the maximum is about 30 meters here to get this distance C between 6 meters and 50 meters. Also, the angle alpha is limited. That means you have to use an angle between 45 degrees and 85 degrees. But that is not a problem. I will show you why. Because if you check the mast adapter here, which is used to connect the NIRS to the pole, you will see that here you have these cuts, and these cuts will automatically limit the angle between 45 degrees and 85 degrees. So normally you don't need to check the angle here because you will always be inside the technical specification because the adapter is cut like this. Okay? So this is not a problem here. Right. So, and based on this information, you will get a surface diameter D. That's the measurement area here, D. And also this can be calculated because this is also depending on the measurement distance C here. And you see the formula is measurement distance C divided through 10. That means, for example, if you have the minimum length of the hypotenuse of C with 6 meters, you will get a measurement area of 60 centimeters, 0.6 meters. You use the 6 meters and divide it to 10. That's it. And the maximum measurement area which you can get is if you use a hypotenuse of 50 meters, you will get a measurement area of 1.5 meters. Okay, I hope this is clear here. The second way to install the NIRS is to install it on a gantry. The principle is the same like on the pole. You see that on the left side, also all the calculations, all the specifications for the length of the hypotenuse and the angle are the same. The only difference is that, oh, not a difference, a special thing here for the gantry is that normally you will install that against the direction of the traffic. You see that? If you see here the arrow, that's the direction of traffic, and you normally install the NIRS on top of the gantry, but against the direction of the traffic. All right, that's a special thing here for the gantry installation. All the other stuff is the same. All right, the calculation of the measurement distance, of the measurement diameter, the calculation of the measurement distance, all this stuff is the same thing. So, good. What are the important things choosing the right location? So the important thing here, you will see that here, we have, I have tried to show that in the pictures. Normally you would generate this measurement area, which is normally between 60 centimeters and 1.5 meters. But you cannot put the sensor or let the measurement area be in all the different surface possibilities. So that means you need to have only asphalt in your measurement area. You will see that. You cannot use the measurement area where you have manhole covers. Why? Of course, the manhole is made of metal, and the reflection of metal is different than the reflection of asphalt. And of course, the NIRS is specially configured for this reflection of asphalt, of standard asphalt. All right. So this is not possible to use the measurement area inside manhole covers, for example. The same thing for road markings. You cannot use the measurement area here inside where you have road markings. The same thing, because you have these white lines and this white paint, this white color will change the measurement. So that's the reason why you cannot use the measurement area inside its road markings. The same thing for potholes or cracks. If you think about, the sensor will do a integration of the area. But if you have a hole there, the integration will be changed because there is more water in the hole than on the surface. And so that's also not possible to do that. The right way is, you see that here with the green arrow, to use or to put the measurement area on a typical asphalt surface. If you want to know where your measurement area is, also this is not a problem. I will show you why. You can check that on site during the installation. We have a special thing here. We have this tube. There is a metal tube which is part of the shipment of the NIRS, and you can put that tube during the installation on the back. There is a hole here. Then you can put the tube inside the hole, and now you can look through this tube and you will see the spot, the measurement area of the sensor. And so you will be able during the installation to check where the measurement area will be. I think that's a nice thing here to check it, right? No problem. Okay. Questions so far? Do you have any questions? If so, please use the question box on the right side of your webinar software. I will now wait maybe some seconds to check if there are some questions. If not, we will go on with the NIRS webinar. No questions? Okay. Oh. There is again the question. So we have now questions. Nice. NIRS measures salt concentration. How NIRS measures salt concentration? Maybe we can go back to this sheet. The freezing point and the salt concentration are calculated. Again, we have a link between freezing point temperature and salt concentration. They are linked together. So if you use the formula, there is a special formula to calculate the freezing point and the salt concentration using this ice percentage level. That means the freezing point temperature and the salt concentration are calculated based on the value of the ice percentage measurement. That means, of course, the ice will also change the reflection of the light. And so we will be able, using our optical measurement principle, to analyze the percentage of ice in the water. And with this percentage of ice in the water, we can use a formula to calculate the freezing point temperature and the salt concentration. Okay? So that's the first question. The second one is, why cracked road impossible? So the reason is, again, the sensor, or in the sensor, we do an integration of the area to get the values, to calculate the values. The integration is based on a flat surface. If you use a place where you have cracks, for example, there is water on the surface, but you have more water in the crack, the reflection will be changed. And so the integration of the value is not the right one. So you get a wrong value, for example, for the water film height. Because the sensor will, of course, also check this crack. But this crack is normally not the reason for a water film. And that's the reason why you cannot put the sensor spot on a crack. The next thing is why we cannot place the sensor in the direction of the traffic. For the gantry, it's a recommendation of Luft. Of course, you can put it against it, but you have to know that we measure light. And what will happen is that if the sensor is installed in the direction of the traffic, the light of the cars maybe can influence the measurement. And that's the reason. To be sure that there is no influence, we will normally put the sensor against the direction of traffic here. Okay. So the next question, why minimum 6 meter? If shorter than 6 meter, what? That's a good question, but you know, we have, again, I have to go back. Our complete system here, if you check it here on this page, with the light source and the receiver, of course, we have done a special dimension, a special calculation. And the receiver, to get right, or to get to the right values to calculate, the light must be inside that specifications. So that means the reflected light, the spot, must be like this. It's depending on the spot here. So if the spot is lower than 60 centimeters, the reflected light is not representative anymore to get analyzed. That's the reason. So it's not possible for the receiver unit to do the analysis with a lower spot. That's not problem. That's not possible. That's the reason. So if the sensor is installed lower, that means if the distance C is lower than 6 meters, the sensor will not work the right way. That's depending on the electronics. Okay? What is critical watt? I think that's not a real good question for this webinar, because that's a special thing. You have to check what is, that's a question of the model, of the road condition model, which is part of the NIRS, of the IRS. You can check that in the manual. Critical watt normally is if you have 0 degrees plus minus 0.5 degrees, and it starts to freeze, and that's critical watt. Okay? But you can check that in the manual, that the description of the road conditions is completely explained in the manual here. How to notice transition participation from rain to snow? I do not really understand this question, but I will try to answer it anyway. So I think what you mean is how to check if there is rain or snow on the road. Yeah, that's again the reflection. If you have rain, or that's not rain, if you have water on the road, the reflection of the light is different than compared to snow. So with this analysis, we can say if it's snow or water. Not rain, not precipitation. That has nothing to do with precipitation here. The NIRS is not able to measure precipitation. That's not a precipitation sensor or a snow height sensor. The sensor NIRS is able to check the layer on the surface, to check the height up to 10 millimeters for snow, up to 2 millimeters for water. That's it. Not a precipitation measurement here. Don't mix that up. Right, so let's go on. Thank you for the questions. So connection, that's nothing special here. You can see that the connection is done like a standard UMB sensor. To use the UMB technology, normally you have the sensor, which is the UMB sensor. You have 4 wires, brown, white, green, yellow, which will be normally connected to our isocon, to our RS485 to RS232 converter. With this converter, you will be able to connect also, for example, a modem or a COM server, and then you can transmit the data to the central PC. So that's a standard installation here, nothing special. You can also add the NIRS to every UMB station, so there is no problem with that. We need 24 volts. We have that's a standard, so there is no possibility to go lower, because you need a stable 24 volts for the generation of the light here. Maximum cable length, maybe that's also important for you, is 50 meters. You can, with the standard cable, you cannot extend the cable more than 50 meters, because again you have a high power consumption because you have this light source. So if you want to extend it, you have to use a thicker diameter of the cable. So the standard cable, which normally is part of the shipment, is maximum 50 meters. So we have two cables here. We have a 15 meter cable, 15 meter cable, and a 15 meter cable, which can be used. So everything standard here for the connection. So power supply, of course, you normally connect it to the isocon, and with the RS232 interface you can connect all different types of modems, directly to the PC and all this stuff. Adjustment. Of course, after the installation, the sensor needs to be adjusted. And you will see that here, you can read that, sensor adjustment. An adjustment is required during commissioning in order to correctly adapt the sensor to the conditions at the installation location. The adjustment will start automatically after switching on the sensor to the first time. That's the main sentence here. The adjustment will start automatically after switching on the sensor the first time. Because we had problems here. Why? The people get the sensor and then they they want to test it. So they switch it on in the maintenance room or in the office, and then automatically the adaptation will be done for this place. Now, if you take the sensor on site and install it, all the measurements will be wrong, because the sensor was adapted for the location in the maintenance room or in the office, for example. Of course, on site you have different conditions, and so you will get, of course, wrong values. So you have to know that. But there is no problem. If you have done it the first time, you can again do the adaptation again. But you have to use UMB config tool. You see that in the last sentence. After that, a renew adaptation on site will only be possible using the UMB config tool. Okay? Adjustment. So what is necessary to do the adjustment, and what are the necessary things here? For the first adjustment and also the following adjustment via UMB config tool, only if necessary of course, the following conditions must be met for the period of checking. That means normally 10 minutes. First, all the installation, assembly and location works must be done. They have to be finished. Second point, absolutely dry road. So that's also very important. The adjustment, the adaptation of the sensor must be done during dry conditions. Third point, no traffic jam on the road. So normally there should be no traffic, because we don't, the cars will influence the measurement, so the adaptation cannot be done with cars on the measurement spot. Fourth point, stable power supply for the adjustment period, of course. That's clear. So that's really important. Dry conditions, all works have to be finished, and installation works, and no traffic on the road, so that the adjustment, that the adaptation can be done the right way. Now I will have some frequently asked questions for you, because that are the questions the people always ask me. So I tried to use this also for this webinar. So first question of the people normally, is it possible to change the height, angle, horizontal position, or even move the complete NIRS31 UMB station after the first installation? Answer, of course, yes. All the mentioned things above can be changed, but that's the big thing. After that, a renew adaptation is a must. Because if you change something, the height, the angle, the horizontal position, the reflection of the light is changed, and the adaptation was done for the position before. So you need to do a renew adaptation. If you don't do that, the values will not be correct. That's a must. Please remember that. So, second question. Is there a possibility to check if the adjustment of the NIRS was done well? Yes, you have a possibility. You can use the UMB config tool. We have a special feature here in the config tool which will tell you if the adjustment was done the right way or not. You can use the menu options, NIRS UMB, check adaption in the UMB config tool. And you will be able to get the adjustment status here. So you will get an information, adjustment was correct or not. If it was not correct, again you can use the UMB config tool to do a renew adaption. And then you can check it again. So that's a pretty new feature here, and so it's easier for the people working on site during the first installation to check if the installation was done the right way. Okay, third question. What happens if during the measurement a car will stop in the measurement area? For example, traffic jam. Answer. The sensor uses an interference suppression. That means for a special time, the sensor will hold the last valid data. Normally, the standard, the time is fixed, it's 40 minutes. After that, you will receive the error code measurement not possible. Okay? So normally, if there are the measurement spot is closed because there is a car, you will get the last valid data for this 40 minutes. After that, if there is still a car on the spot, you will get the error code measurement not possible. So now to the last point for today, we have the maintenance. If you need to do a maintenance, what is required? You see that the following parts are required for maintenance. A hexagon socket wrench, size 6, and the reflector unit. So I will show you, first of all, I will show you the wrench here. That's something like that, a typical wrench, size 6. Because during the maintenance, you have to open these two screws here. And that's a special imbus wrench, and you have to use this special key here. Maintenance. Maintenance on the sensor must be performed in accordance with the indication remaining time to next service. This is a channel which you can check if you read out the sensor. This is due approximately once annually. The following works must be carried out. Replace the reflector unit, that's a must. Every year you have to replace the reflector unit because the light source normally will not work more than 1 year. That means normally it's more than 1 year, but to get sure that the sensor will work the right way, we say to replace it every year. Clean the transmitter and the receiver plate. After that, do a function test, or if it's needed, do a renew adaptation using UMB config tool. I will show you how to do that now. So, of course, here are the plates which you should clean. These are the filters and plate and the light source plate. You can use a cloth which is a little bit humid, and that's nothing special. Don't use any cleaner or something like that. Only clean it with a cloth which is a little bit damp, and that's okay. So now you can open the unit to change the reflector. I will show you how to do that. So you use your wrench here and open the screws. So I will get out the screws. Normally you don't need to do that because the screws are secured. So they normally cannot fall out or fall on the surface. So after that, you can open the unit. And it looks like that. maybe I can explain what you will see here now inside the NIRS. So here, this part, maybe you can show it like this. This part is the pyrometer. This part is the small electronic motor to turn the filters, and we have here at this part we have the receiver, and this big round thing is the reflector unit, and this needs to be changed, and that's easy to do. You have some spirals here, 3 spirals, one here, and one here. That's here. I will show that from this side. Here the spirals, and it's easy. You can loosen them. One, second one here on the right side, and the last one here. So that's it. You have to disconnect the power connector here, and then you can change it. That's it. It's really easy. And that's the complete reflector unit. That's the reflector and the light source inside. After that, you can put the new one back. You can now connect the complete unit here with the spirals again. 1, 2, and 3. And you have to connect the power connector again to the same connector here. So that's it. And that's what you have to do during the maintenance. After that, you can again do a renew adaptation. You have to close the NIRS first, of course, so you can close it, no problem. Of course, you have to fix the screws again. And then you are ready to do the renew adaptation and check the function of the sensor. That's all. So that's nothing special here, not a big thing. So the reflector can be changed easily here. That's it. All right, so that's the maintenance. Questions? Do you have any questions now regarding the maintenance, or also regarding the installation, the adaptation? No questions? Okay, so thank you very much for your interest. That's all for today. I hope you... Oh, there is one question coming now. What about the price of the reflector unit? Yes, okay. The price is about 15 euros for one new reflector unit. 50 euros, 50. Okay, so again, thank you very much for your interest. I hope you will join also now new other webinars here. It would be a pleasure for me to do that, to do new webinars for you. Please check our homepage for the future webinars and for the future topics. Again, a new question. So before ending the webinar, I will try to answer also the last question here. What about concrete road surface? Yes. We have a possibility to change the emissivity of the sensor. That means the how the structure of the surface is made. The standard configuration of the NIRS is based on standard asphalt, and it's a value between 0 and 1, and we have entered here 0.95. You can change that, but we do not know what are the different values which you can put in, because we cannot test every concrete version or every concrete type. So normally it's a standard value for dark asphalt. If you have brighter asphalt, you have to go more down with this value. That means 0.9 or something like that. But there is no formula for that from our side. We have made our test with a standard asphalt, and we have put this value as a standard value in the configuration of the NIRS. But you have the possibility to change it. Can we change the reflector unit on site? Of course, it's extra made for that. So that's the reason why you have only 2 screws to open. It's easy to open them. They will not fall down because they are secured normally. You can open the complete NIRS with 2 screws, opening these 2 screws, and then you will be able to change the reflector unit on site. The only thing is you need a ladder or something like that to go up, and then you can change this reflector unit on site. You don't need to send the complete NIRS back. No, that's a maintenance work which you can do on site. Okay, so thank you very much again. Hope to see you again, and it was a pleasure for me to do this webinar for you. Enjoy the day. Bye bye.